All right, we are going to continue to talk about the power of exponential growth and how it relates to what we learned in class. So if you take a look at page 7 of your notes, we're looking at question number 3. It's asking us to understand the difference between f of n equals 2n and f of n equals 2 to the nth power. So question A says to complete the tables below and graph the points on a coordinate plane for each of the formulas. So if n is negative 2, remember if I want to figure out what f of negative 2 is, I just plug in negative 2. So it would just be f of negative 2, which is equal to 2 times negative 2, which is negative 4. All right, so this right here would be negative 4. Same thing, if I wanted to figure out what f of negative 1 was, I would just do 2 times negative 1, which I end up getting negative 2. So this right here is negative 2. Please press pause and go ahead and fill in the rest of the chart and then come back to me to see if you got the right answers. All right, so you should get negative 4, negative 2, 0, 2, 4, 6. You should be able to easily tell that this is a linear function. So let's go ahead and graph it out. So just graph out your coordinates. So I'd go to negative 2, negative 4, put a dot there. My next coordinate would be negative 1, negative 2. So I'd go to negative 1, negative 2. Next would be 0, 0. And I would just keep going with my graph. So here are all of my different points that I should get. So I have a dot here, a dot here, and a dot here. Find some type of straight edge that you have at home and go ahead and connect the dots. You should get a line for this right here. So I'll go ahead and connect the dots. So my line would end up looking like this, just like that. All right, and don't forget to put your arrows. So this right here is my graph for f of n. All right, now let's figure out what my graph is going to be for g of n. So to figure out what g of n is, I would just do, I would plug in these values every time I see an n. So I'm going to do g of negative 2 equals 2 to the negative second power. Now do not forget that if I have a negative exponent, it means I have to take this number and do the reciprocal of it. So this means that it's going to be 1/2 to the second power. So it's 1/2 squared, which is just 1/4. Okay, so this one right here should be 1/4. All right, go ahead and look at g of negative 1 with me. So I'm going to figure out what g of negative 1 is. So g of negative 1 is going to be 2 to the negative 1 power, which means I would get 1 over 2 to the first power, or just 1/2. So this right here is 1/2. I want to figure out what g of 0 is. So it would be 2 to the 0th power, which remember, you should know that anything to the 0th power is always going to be the number 1. Please figure out the remainder of the chart and then press pause and come back to me to see how you did. Okay? All right, so right here you should get 2, 4, and 8. And we'll go ahead and graph out these points. So negative 2, 1/4 is about a quarter of the way up between 0 and 1. So I'll put a dot right there. Negative 1 followed by 1/2 is halfway up, so I'll put a dot right here. 0, 1 is right here, and 1, 2 is going to intersect right here. 2, 4 is going to intersect as well right here, and then 3, 8 would be right here. And then if you think about it, 4, if I wanted to graph out 4 would be all the way up here at 16. So here's another example of how it starts off really small, and this is growing at a faster rate, but eventually we get to a point where the exponential graph is going to be growing faster. So go ahead and connect your dots. Try to connect it as best as you can. I'm going to connect it as best as I can, considering that I am doing this with a tablet, so I'm just trying my best. All right. And of course, it should be a more gradual curve, okay? So then this right here would be g of n. Now question B says Describe the change in each sequence when n increases by 1 unit for each sequence. So every time n increases by 1, f of n is increasing by 2, by a common difference of 2. So what we would say is that for f of n, we can just say that it has a common difference of 2. So that means that it would be arithmetic, all right? This would be arithmetic. All right, and then for g of n, it has a common ratio of 2, so it's being doubled each time. So that means r equals 2, which means that this would have to be geometric. All right, so this is what we need to do. In number 4, you invest $5,000 in a bank that offers an interest rate of 4% compounded annually. Find out how much money you would have in the bank after 1 year. So first of all, we know that at the beginning we have $5,000 in our bank. So right here we know that f of 0 is 5,000. Okay, and I want to figure out how much I'm adding into the bank. Now, if it's at an interest rate of 4%, that means that I just have to figure out what 4% of 5,000 is. And if you remember, 4% is just 0.04. So I'm just going to figure out what 4% of 5,000 is, I just have to multiply those two numbers together. So go ahead and multiply 5,000 by 0.04, see what you end up getting. You should get $200, all right? But that's the extra money that you get from the interest, all right? So you originally had 5,000, and then you added another $200 onto it, so you get $5,200. So that's the answer to question A. You know that after 1 year, you'll have $5,200. But I want to talk about question A a little bit further. Do you guys understand how this right here is a whole? So this is the whole amount that you started off with. And then this right here is 4% of what you started off with. Now a whole is 1, and 4% is 0.04. So I'm figuring out what 104% of 5,000 is. So watch this. I could have just done a shortcut of 5,000 multiplied by 1.04. Go ahead and multiply that in your calculator, see what you get. And you should end up getting $5,200. All right, so there's your shortcut to figure this out. So now I have to do the same thing, except this time it's going to be after 4 years. So I want to figure out how much it's going to be after 4 years. I know that after 0 years, right at the beginning, I had $5,000. And I know that after 1 year, I have $5,200. So now I have to figure out how much it's going to be after 2 years. Well, after 2 years, it's just going to be 104% of what it was after 1 year, because each year it's 4% of the previous amount. So here's your recursive formula right here. You don't have to write this down. I just want to make sure that you guys kind of get this. So the recursive formula is f sub n plus 1 equals 1.04 times f of n. Okay? So here I'm going to figure out what f of 2 is. I have to just take 5,200, which is the previous amount, and multiply that by 1.04. So I end up getting $5,408. Don't forget to actually do this in your calculator so you can make sure you get that. So that's how much you get after 2 years. But I need to keep going with this because it asked for 4 years. So I would figure out what f of 3 is. So I would take $5,408 and multiply that by 1.04 again. And I end up getting, do this in your calculator please, $5,624.32. Okay, I'm not quite done yet because this is after the 3rd year. Now I have to take the 4th year, and to figure out the 4th year, I have to take the 3rd year and multiply that by 1.04. So then I end up getting $5,849.29. Okay? Now, mathematicians like shortcuts. So in question C, it asks you to figure out how much you're going to have to pay after 20 years. And that's just going to get crazy insane because you don't want to have to do this 16 more times, right? So what is the pattern? What is happening? So let's talk about this. F of 0 equals $5,200, all right? F of 1 equals $5,200 multiplied by 1.04. Okay? Now, f of 2 was equal to your answer from f of 1. So here, this whatever this number is my answer to f of 1. Again, you don't have to write this down. Just watch this so you get this. So do you understand how this is still just f of 1 right here? And then I have to multiply it by another 1.04. Okay? And then to figure out what f of 3 is, I would have to take 5,000, or my f of 2, which is this whole thing right here. So 5,200 times 1.04 times 1.04. This is what f sub 2 is, right? So this right here was what I got for f sub 2. I have to multiply it by another 1.04 to get f of 3. So hopefully you noticed what's happening. So in this problem right here, I'm taking 5,200 and I'm multiplying it by 1.04 0 times. Here I'm taking 5,200 and I'm multiplying it by 1.04 1 time. Here I'm taking 5,200 and I'm multiplying it by 1.04 2 times. And here I would take 5,200 and multiply it by 1.04 3 times. So hopefully you notice the pattern. Hopefully you see that when it's f of 0, it's to the 0th power. When it's f of 1, it's to the 1st power. F of 2 is to the 2nd power. And f of 3 is to the 3rd power. Let's write out the formula for f of 4. So f of 4 would say 5,200 times 1.04 to the 4th power. I want you to all type that into your calculators, please. See what you get. When you type it into your calculator, you will end up getting about $5,849.29. Okay, so this is your answer, another way to do it. So let's do question C, 20 years. So I'm going to figure out what f of 20 is, and I'm just going to take 5,200 and multiply it by 1.04 to the 20th power. Okay, and then you end up getting $10,955.62, which is not a bad deal at all. Now, question D asks us to write an explicit formula to represent how much money you get in T years. So that should be easy for you because the explicit formula is f of n. So we know that it's always going to be 5,200 based on what we just discussed times 1.04 to the nth power. But another reason why this should make sense to you is because we discussed that a sub n, if it's geometric, is always going to be a sub 1 times r to the n minus 1 power. And remember, we have to raise this to 1 less than n power because we already have our a sub 1. But if we have our a sub 0, I don't have to raise it to 1 less power. It's just r to the n power. And this right here is your a sub 0. And this right here is your n power. Okay? So this formula should make sense to you right here. Make sure that you come to next class with any questions you have. All right, so let's look at number 5. It says a typical thickness of toilet paper is 0.001 inches. Seems pretty thin, right? Let's see what happens when we start folding the paper. So question A, how thick is the stack of paper after 1 fold? So we know that after 0 folds, that it is 0.001. So then each fold of the paper is twice or doubles the size of the paper, because when you fold a piece of paper, you now have 2 pieces put together instead of 1, so you're doubling it. So a sub 1, after 1 fold, it will be 0.002 inches. Okay, so that's the answer to the first part. And then we'll say inches. We'll use the inches format. So then a sub 2 is after 2 folds, and that would be 0.004 inches. Okay? And then it asked us to figure out after 5 folds. So let's figure out what a sub 3 is going to be, a sub 4, and then we'll use the information to figure out what a sub 5 is. So go ahead and figure out 3, 4, and 5. Okay, so you should end up getting 0.008 inches. 0.016 inches, which means that after 5 folds, it's 0.032 inches. Now remember, with exponential growth, and this is exponential because it's geometric, with exponential growth, it's going to increase slowly at first, and then it'll get faster and faster and faster. So question B, write an explicit formula for the sequence that models the thickness of the folded paper after n folds. So we know what the formula is going to be. We know that it's going to be a sub n equals the initial amount, which is 0.001, times r, which is 2, because it's doubling, to the nth power. And that should make sense to you, because right here, a sub 2, we did 0.001 times 2 squared. All right, so this is our explicit formula. Now question C asks, after how many folds will the stack of folded paper pass the 1 foot mark? So I want you guys to think about this one, see if you can figure out how many folds it would take. Just take a couple minutes to think about it, and next time I see you in class, we will talk about this and see how you did, and we will also figure out how many times you need to fold the toilet paper to reach the moon.